Think-tankonline learning. In this video, I'm going to look on Laplace transform. Okay, so I want to evaluate the Laplace transform for the functions which I'm going to write here. So I'm going to use trigonometric identities in order to evaluate Laplace transform of functions, and I'm going to use the shift theorem, and I'm going to use the derivative of transform property, and on the last part, I'm going to find Laplace transform using the combination of these theorems. So the first problem in which we're going to use the trigonometric identities, I want to find the Laplace transform of cos 3t squared. Okay, so in the first problem which we're going to use the trigonometric identities, I want to find the Laplace transform of cos 3t to the power 2. Okay, so this is the same as writing the Laplace transform of cos squared 3t. Okay, so now what we know, we don't have the Laplace transform of cos squared x or cos squared t, but we know from the identities, we know that cos 2 theta, in this case our angle is 3t, so I'm going to write cos t is equals to 2 cos squared t minus 1. Okay, and if we make cos squared t such with the formula, we're going to see that cos squared t is going to be equal to 1/2 of cos t plus 1/2. Okay, so that means the cos squared of the angle t is equal to 1/2 cos t, and in this case our angle is 3t, so that means cos squared 3t is equal to 1/2 cos, instead of writing t here, we're going to write 3t plus 1/2. Okay, and you know the Laplace transform of cos x. Laplace transform of cos t is equal to s over s squared plus a. And a is the coefficient of the angle, right? Is the coefficient of t. A is the coefficient of t. So now from this, what we know is going to be easy to evaluate the Laplace transform of 1/2 cos 3t plus 1/2. Okay, what is going to be the answer? I'm going to say 1/2, which is a constant. I'm just going to write it like this. And for s, we're going to write s, and you're going to write s squared plus the coefficient of t, which is 3 squared plus 1/2 times 1s, because Laplace transform of 1 is 1 over s. Okay, and I think I'm going to simplify here. So this is equal to s over 2 s squared plus 9 plus 1 over 2s. That is the answer. Okay, now we're moving on to the next question. We want to evaluate the Laplace transform of cos 2t sine 2t. Okay, so for this one, what do we know? We know that 2 sine x cos x is equal to 2 is equal to sine 2x. So we're going to use this identity to evaluate the Laplace transform of cos 2t sine 2t. Okay, so what do we know? We need a 2. So we're going to write a 2 in order for us to achieve this identity, to obtain this identity. So I'm going to write 2 cos 2t sine 2t. Okay, but we don't have 2. Our original function don't have 2. So what we're going to do, we're going to divide this by 2. As you can see, 2 into 2 are going to get 1. So we have just changed the appearance, but the value of this function is still the same. So this is the Laplace transform that we want to find. And from this identity, we know 2 sine x cos x equals to sine 2x. And in this case, the angle is x. So what we're going to do, we're going to multiply the magnitude of the angle by 2. So in other words, we want to find the Laplace transform of sine 2t times 2, 4t. Okay, and you know the Laplace transform of sine x or sine t is equal to a over a squared plus a squared. So this follows that the Laplace transform of sine 4t is equal to, for a, which is the coefficient of t, it's going to be equal to 4 over s plus 4 squared. So I'm going to write s plus 4 squared, and what is going to be the answer? It's going to be 4 over s squared plus 16. I have omitted this half. Okay, still have 2 here, because this is the only thing that is going to change to sine 4t, but we still have this 2, because I say this one is equal to this one, so that means we still have 2. So I'm going to just put a half right here over 2. I'm going to put half right here. I'm going to put half right here. So this becomes 2 over a squared plus 16. Now we're moving on to the next question. We want to find the Laplace transform of sine 3t minus 4. Okay. And in this case, we're going to use compound angle formula. Okay, so you know that for sine, if we're given sine A plus B, this is same as saying sine A cos B plus cos A sine B. So I'm going to do the same here. So I'm going to write here the Laplace transform of sine 3t minus 4 is going to be the Laplace transform of sine 3t cos 4 minus cos 3t sine 4. And you should know that, you should see that cos 4 and sine 4 are just constants, are like numbers. You can evaluate that using a calculator. You can just leave them like that. So here I'm going to write it as cos 4. I'm going to pull it out of the Laplace transform. Cos 4 sine 3t, and here minus sine 4 Laplace transform of cos 3t. And we know the Laplace transform of sine and the Laplace transform of t. So I'm going to write cos 4 the Laplace transform of sine, which is going to be a, which is 3 over a squared plus a, that is 3 squared, minus sine 4, which is a constant. The Laplace transform of cos 3t is s over a squared plus 3 squared, which is a. Okay, and I'm going to be left with 3 cos 4 over a squared plus 9 minus, and this one is s sine 4 divided by s squared plus 9. So now we're done on Laplace transforms using trigonometric identities. Now we're moving on to the shift theorem. So on shift theorem, what you know, if you want to evaluate the Laplace transform of a function called ft, this is going to be equal to the integral from 0 to infinity of e to the power negative st of ft dt. Okay, dt, which means we're integrating with respect to t, so that means s is a constant. Okay, so let's say we're given a problem in which we want to evaluate the Laplace transform of e to the power at ft. Okay, so we're going to follow the same procedure, or we're going to use this same formula. Okay, so we're going to integrate this from 0 to infinity. Okay, and we're going to write e to the power negative st, and we're going to write this e to the power at ft dt. This is this formula and this formula just the same. Okay, ft in this case is e to the power at ft. Okay, and we're going to use loss of indices since e and e, so that means we have same base. we have e and e, so it's going to be the Laplace, the integral from 0 to infinity, and we're going to add here, and if you add your things correctly, and after that, if you factorize, you're going to obtain e to the power negative s minus a ft dt. Okay, so as you can see, I've said s is a constant, so that means s minus a is also a constant here because we're differentiating with respect to t. So I'm going to use the substitution. Instead of writing s, I'm going to write s minus a. Okay, so this is all about the shift theorem. So now I'm going to solve the problems using shift theorem. So first of all, want to evaluate the Laplace transform of e to the power negative 3t sine 2t. Okay, so as you can see, this problem is in form of the Laplace transform of e to the power at ft, in which ft equals to sine 2t. So what we're going to do, we're going to deal with ft. So let's find the Laplace transform of sine 2t. And you know that the Laplace transform of sine 2t is going to be equal to a over a squared plus a squared. Okay, and a is equal to 2, so it's going to be 2 divided by a squared plus 3 squared. Okay, it's 2 squared here, 2 squared. Okay, so by the shift theorem, remember, for every value of s, we're going to substitute s with s minus a. Okay, so that is the substitution which you're going to use. But from this, I said s minus a is also a constant. So I'm going to write here, for a, I'm going to write 2. And for s, I'm going to say s minus a, and a is the coefficient of t, and the coefficient right here is going to be minus a, which I'm going to say minus 3 plus a, and a is 2 squared, so I'm going to write 2 squared here, and it's going to 2 over s plus 3 squared, 3 plus 3, s plus 3 squared plus 4. Okay, and we're going to simplify here, so it's going to be 2s squared plus 6s plus 9 plus 4, which is equal to 2 over s squared plus 6s plus 13. Okay, and let me repeat here. I've said that a Laplace transform of sine is a minus s minus a plus a squared. Okay, so what we're going to do, we've said for every s, wherever there's an s, we're going to substitute that, we're going to replace it with s minus a. So here what we have said, okay, so here what we have done here, we have said a divided by s, where that's a, from this squared plus a. Okay, and this a is the coefficient of t, and this a is the coefficient of t in the value of sine 2t. Okay, now moving on to the next question, I'm going to use the shift theorem. Want to evaluate the Laplace transform of 1/2 e to the power 3t cos squared t. Okay, so what we're going to do here, we're going to use the shift theorem, because we can write this as 1/2, which is a constant, the Laplace transform of e to the power 3t cos squared t. Okay, so this is in form of e to the power at ft, in which ft is equal to cos squared t. And I've already shown you how to find the Laplace transform of cos squared x using trigonometric identities. So here we've said, so here what we're going to do, we're going to write this as 1/2 the Laplace transform of e to the power 3t, and for cos squared x we're going to use the identity which is 1/2 cos 2 theta. In this case, it's going to be cos 2t plus 1/2. Okay, and this is equal to 1/2 the Laplace transform of e to the power 3t. 1/2 times 1/2, so I'm going to let us write 1/2 here. Cos 2t plus 1/2 e to the power 3t. Okay, and I think it's now easier to evaluate the Laplace transform of this one. Okay, so I'm going to write 1/2 times 1/2, we're going to multiply that and get a quarter. And the Laplace transform of cos 2 of course t is going to be equal to s, but remember we have a function which is in form of e to the power t and ft, so I want to write s minus a because we're going to use this substitution. Okay, divided by s squared, so we're going to write s minus a squared plus a. Okay, and we're going to say again 1/4. 1/2 times 1/2, which is going to give us 1/4 e to the power 3t. Okay, and they'll say this a from the substitution is the coefficient of t on the exponential function, so I'm going to write 1/4 s minus 3 divided by s minus 3 squared plus a, which is the coefficient of t on the Laplace transform of ft. Okay, on ft, in this case, it's going to be equal to 2 plus 1/4. And know the Laplace transform of e to the power 3t is going to be e, which is going to be 1 over s minus the coefficient of t, which is 3. Okay, and now we're going to simplify here. This is going to be s minus 3, and we have 4, and it's going to be s squared minus 6s plus 9 plus 4 plus 1/4 of s minus 3. Okay, and this is going to give us s minus 3, and here I'm going to get 13, so I'm going to get s squared minus 24, and I'm going to say 13 times 4, which is going to give us minus plus 52 plus 1 over 4 s minus 3. So this is the answer. Okay, and now we're moving on to the Laplace transform using the derivative of transform property. So we use this property when you have problems in form of t to the power n of ft, where n is any number. It can be 1, 2, 3 going on. Okay, so we use this formula. This is the n, the Sn. So I'm going to use differentiation here. Okay, so how I'm going to do that, I'm going to show you. First of all, I want to evaluate the Laplace transform of t sine 3t. Okay, so you should know that we haven't done in problem like this. It's not the same as e to the power at of ft, but it's just a different. And in this case, the first thing that we have to identify is what is the value of n, and from this we are seeing that n is going to 1, where this is t to the power 1. Okay, so what we're going to do that, first of all, we're going to find fs. What is fs? The Laplace transform of sine 3t. So I'm going to write fs is going to be the Laplace transform of sine 3t. And what is the Laplace transform of sine 3t? I think we've already done that. It's going to be a, which is 3 divided by s squared plus a, which is 3 squared. Okay, and this is equal to 3 over s squared plus 9. So what we're going to do now, we have our f of s, we have the value of n. So I'm going to write Laplace transform of t sine 3t is going to be -1 to the power 1 okay, ds of fs. What is fs? Which is 3s squared plus 9. Okay, and we want to differentiate here with respect to s. So I'm going to have negative here. I'm going to write this as s squared plus 9 to the power negative 1. So this is what I want to differentiate here. ds. Okay, and if we do that, we have negative 1 right here. We're going to drop the power. We're going to have negative 1, and we have 3. We're going to write 3, and we have s squared plus 9 to the power negative 2, because we're going to take away the power, and we're going to multiply it by the inner derivative of s squared, which is 2s. So negative times negative is positive. 2 times 2, that is going to give us 6s divided by s squared plus 9 squared. So this is the answer using the derivative of transform property. Okay, it's the derivative of transform property. Okay, I want to do another example here. I want to find the Laplace transform of t squared e to the power t. Okay, and from here we know that n is equals to 2, and we're going to use our formula. So what is going to be our formula? First of all, I want to find fs, which is the Laplace transform of e to the power t, and that is going to be 1 over s minus 1. Okay, so now Laplace transform of t squared e to the power t is going to be negative 1 to the power 2 d2 f of s, which is 1 over s minus 1 over ds2. So that means we're going to differentiate this function twice. So if we differentiate this one, I'm going to write it as s minus 1 to the power negative 1, and we have said negative 1 squared, that is going to give us positive. So I'm going to write here ds, and that's going to be the answer. We'll drop the power negative 1 s minus 1 to the power negative 2 times the inner derivative, which is 1, and we're going to differentiate that again. We're going to write ds of negative 1 s minus 1 squared times 1, and this is going to give us, so this is negative 2. We'll drop the power. We're going to have negative 1 times negative 2 s minus 1 to the power negative 3 times the inner derivative of s, which is 1, and negative, that's going to give us positive. So we're going to have 1, it's actually 2 s minus 1 to the power 3. Okay, and now we're moving to the last section, where I want to find the Laplace transform using the combination of the property we have learned so far. Okay, so on our last part, we're going to use 2 or more properties. So this is the type of problem where we are going to use a combination of properties. Okay, so in a given problem like this, remember we have 2 functions. We have t squared e to the power negative 2 and cos 3t. Okay, so what I'm going to do, I'm going to start from the right hand side. I'm going to say let the g of t, the function g of t, be equal to cos 3t, and function h of t be equal to e to the power negative 2t cos 3t. But I've said cos 3t is equal to g of t, so this is negative e to the power t g of t. Okay, and before I go further, we should remember that we've evaluated the Laplace transform of functions, in which we've evaluated Laplace transform of function in form of e to the power at of ft, and this is the type of the functions which evaluated. Okay, now ft, what is ft? What is that? Ft is going to be is equal to e to the power negative 2t cos 3t. Okay, and if e to the power negative 2t cos 3t is same as ht, so this is equal to t squared t squared h of t. Okay, you should also remember when we evaluated the Laplace transform of functions in the form of t to the power n of ft. Okay, so in this case we're going to use the derivative of transform property, and we're also going to use the shift theorem. So first of all, we're going to start with the shift theorem. Okay, so for the shift theorem, what I'm going to write on the Laplace transform of e to the power negative 2t g of t, and g of t is equals to cos. It's going to be the Laplace transform of cos t, it's s, but this in the shift theorem is going to be s minus a over s minus a squared plus a, and we've said it's s minus a, which is the coefficient of t on the exponential function. It's going to be negative 2 divided by s minus a, which is also the coefficient of 2 on the exponential. It's going to be negative 2, and I'm going to square this one. I'm going to say plus a squared, the coefficient of t on g of t, or f of t. In this case is 3, so I'm going to write 3 squared here, and this is going to be s plus 4, right? It's going to be s plus 2, it's actually s plus 2, and they're going to have s plus 2 squared plus 9, and this is going to be s plus 2 divided by s squared plus 4s plus 4 plus 9, and this is going to be s plus 2 divided by s squared plus 4s plus 13. Okay, so now we have managed to arrive right here. Okay, and so that means in order to evaluate the Laplace transform of functions in the form t equals t to the power n f of t, we use the derivative of the Laplace property, which is going to be equal to negative 1 to the power n dn f of s divided by d Sn, and in this case f of s is s plus 2 divided by s squared plus 4s plus 13. Okay, so now n is 2, because we have t squared here, so that means n is 2. So the Laplace transform of t squared e to the power negative 2t cos 3t is equal to negative 1 to the power 2, which is positive 1, d ds 2 of s plus 2 divided by s squared plus 4s plus 13. We're going to use quotient rule, and this is the formula for quotient rule. Okay, so first of all, for the first derivative, we're going to say v, which is s squared plus 4s plus 13, the derivative of s plus 2, that's going to give us 1 minus s plus 2, and the derivative of the numerator, which is 2s plus 4 divided by s squared plus 4s plus 13 squared. Okay, and if we simplify, we're going to get s squared plus 4s plus 13 minus s squared 2s squared plus 4s plus 4s plus 8, right? 2s squared plus 4s plus 4s plus 8, all divided by s squared plus 4s plus 13 squared. And what is going to be the answer here? Going to have s squared minus 2s squared, that's going to give us negative s squared. 4s minus 4s minus 4s, so only have 4s here. 13 minus 8, that's going to give us negative 5 divided by s squared plus 4s plus 13 squared. Okay, so now let's say this is equal to x. So now I want to find the second derivative of this function with respect to s, which I've called x. Okay, so if we differentiate this, what we're going to get, okay, using the quotient rule, v, which is s plus 4s plus 13 squared, and the derivative of the numerator is going to be negative 2s here, negative 4 minus negative s squared minus 4s minus 5 times the derivative of the numerator. I'm going to drop the power and I'm going to have 2, and here I'm going to multiply by the original function, which is plus 4s plus 13. I'm going to drop power, so I'm left with positive 1 times the derivative, the inner derivative, which is 2s plus 4. Okay, and we're going to divide this by s squared plus 4s plus 13 squared. Okay, so this one will be 13 to the power 4, since I'm saying v squared, and v squared is this to the power 2. So if you multiply it, or if you square it, we're going to get this to the power 4. Okay, so here what we're going to do, we want to simplify our work. We have s squared plus 4s plus 13 squared, and we have s squared plus 4s plus 13. So you can factor out s squared plus 4s plus 13. Okay, and if we do that, what are we going to get? We're going to get, okay, we also have negative here. So I think since we have 2s plus 4 here, we have negative 2s plus 4, I can just factor out negative. So I'm going to have negative this one to this one. I'm going to have s squared plus 4s plus 13 multiplied by 2s plus 4 minus, here we have 2s plus 4 multiplied by negative s squared minus 4s minus 5 divided by s squared plus 4s plus 13 to the power 4. Okay, and this one will get into this one, and I'm going to be left with the numerator to the power 3. Okay, and here you can factorize here. Okay, so if you factor 2s plus 4, we're going to be left with the negative s squared plus 4s plus 13 here. Okay, minus 2 negative s squared minus 4s minus 5 divided by x squared plus 4s plus 13 squared. Okay, and if we simplify here, okay, let me write it on top. So if we simplify, you're going to have 2s. Okay, we can actually factorize here. You're going to have 2s plus 2. Okay, and we're going to have negative s squared plus 2s squared, and that is going to give us s squared. We're going to have negative 4s plus 8s, and we're going to have plus positive 4s. We're going to have negative 13 minus plus 10. If we say this is negative 13 plus 10, and we're going to have negative 23, or divided by s squared plus 4s plus 13 squared. Okay, so thank you for watching. Don't forget to subscribe to our YouTube channel so that you won't miss the next video.